the next slide is talking about the DHCP process. So very quickly, if anyone can tell me what are those processes DHCP server goes through? And what is DHCP first of all?
Dynamic host configuration protocol.
Why do we need it?
We use the DHCP to assign IP address to the host in a server environment.
Yeah, you both are right. But my question is, when we can assign the IP address statically, why do we need DHCP then?
It's
to not having error, because you can assign, I mean, and if it is a big number, it's going to be...
Exactly, this is my question, the answer that I'm looking for. Let's suppose you have 1,000 devices in your infrastructure. What are you going to do as a network administrator? You will go one by one?
No.
It's overhead. So just to reduce overhead, we use DHCP server. Other than that, it's also very helpful and handy, not only handing over your IP addresses, but also some other options we can use. What if we have voice over IP phones? This is like, I'm just going beyond the concepts. Okay, just leave it. And can somebody tell me what are the process DHCP use? What that process known as?
It's a cartoon.
Yeah, which explore all the time.
DORA.
Exactly. So now you will never forget this. Just remember the DORA, because the DHCP is just, or the host machine is discovering for the DHCP server, and they have to go through this process called DORA process. So yeah, before I go into the slide, because this is this concept basically very first of all informative, and most of the questions, to be very honest, come from the DHCP. I just want to know, we have host machine here. This is your computer. And we have the DHCP server here. We have, let's say, the switch as an intermediate device, and they are connected. Currently, your computer does not have any kind of IP. Of course, you want to assign IP addresses using the DHCP server. How it is going to know about the DHCP server if it has no information? If it has no any kind of information, how on earth this computer is going to know that this is the DHCP server and I'm going to get the services from it? Any idea?
This might not be the answer you're looking for, but do you mean like when the computer has to request the IP address from the DHCP server, like obtain automatically?
No, when it boots up, it does not have IP information. Okay. So behind the scene.
Oh, sorry.
Yeah. Danish, can you elaborate more what I'm asking maybe?
Yeah, what he's asking basically, if a computer is turned on Heifer and Christelle, at that point, it doesn't know anything, right? It doesn't even have its own, like, what is that address that it needs, that computer needs, or the networking that it needs to go out and say, hey, I have this networking going on inside this machine, and I'm gonna do this process. What is that? What he's asking, like, even before going after requesting. Requesting is when the networking is, everything is done, right? So what is that piece? Do you guys know?
A PIPA?
Okay, but that comes when the DHCP is not handing over, but we have DHCP.
That's when a computer is already requesting and saying, I need an address, but nothing comes in reply.
Is this where DORA comes in?
Okay.
Kind of, yeah.
Yeah, but okay, no problem. I
Is
think
it from
they
the
have,
network interface card? It's like, oh, hey, I don't have an
no.
address. Hello.
Yeah, of course. But what will be the address? Means I am asking how this computer is going to know, and how what means what is it gonna do to reach the DHCP?
When you turn it on, it's going to search for a network,
Yes.
and the DHCP is
Okay.
going to
Yeah.
respond.
Good. Yeah. Somehow you are near. Okay, let's hit that concept. The first thing that happens, this is called discover. If we talk about the DORA, the first packet is the discover packet. And can you tell me this packet will be sent by who?
Oh, the host.
Yes, because this is in question. He is looking for the DHCP server. If you notice, this is a very important concept. If you have gone through this idea, you will never forget this, even if you will hit CCNP and CCI, because DHCP is going to haunt you all the time. Even if you will hit the CCI lab, you are going to do so many things on the DHCP. So let's see, the source is what? 0.0.0.0. Even it doesn't know about himself, what I am. And where it is heading? 255.255.255. So it is just blindly sending the request or discover packet to your network and have no idea where is the DHCP server. Okay.
Okay.
So yeah,
In the
so this,
same network. So it's actually a really good example. If you look at it, the computer don't have anything, not even any address. We're not talking about loop address. We're not talking about PIPA. We're not talking about any IP addresses. Now here you see 000, and if the destination is saying 255.255.255.255, anything in that network, I am looking for someone who offers IP addresses. So you see the concept over here, right? Now,
Yes.
the machine's turned on. If it has any type of networking going on, it's going to hit those areas with those. And there's actually a UDP, and the port numbers are also explained. You remember people ask you in the interview, what is the two ports people use for DHCP? That's where it comes from. If you look at it closely,
yeah.
68 and 67, that's very important, because if somebody asks you, I'm not talking about DORA. I'm talking about what happens on the machine. Can you explain that? Then this is what they're looking for.
So this
that
is
make
how it
That
is
makes
going.
sense, yes.
Sorry for. Can I continue, Danish?
Yep. Go ahead.
Okay. So source is 00, destination is 255.255 all the way to 255. But these also very important. This is written boot PC. I am coming from 68. I am going to where? 67. These are the protocol, the port numbers. Means I'm going to 67 port, which belong to my DHCP server. Wherever it is, whoever it is, the possibility and the chances are we have multiple DHCP servers sitting in our LAN environment, and they are handing over the same subnets. So in this scenario, my source is nothing. I don't know about myself. I'm looking for the DHCP server which is having 67 number of the port, and it should be work on the UDP, and it could be any destination. 255, this all it means the broadcast. This is gonna, just a minute. This server is gonna receive, this server is gonna receive, this server is gonna receive. But who will receive first is going to entertain your host machine. The second packet is offer. As you can see, we have not received the IP. It is just offering that this is the thing that I have and I can offer. The request is the source now this time, as you can see, it is just like flipped. Now the source is well known, not well known, the IP address of the server, which is 10.0.0.100. And it is generating this request from the well-known port 67. This is for the DHCP server. And I'm going to the client with the destination IP 255.255.255. Okay. So this is the offer. The third part is request. Still, I have not received the IP. Now I'm going to request to the server, kindly can you give me the one that you sent me as an offer? Still, you can see the source is this, and the destination is, because it hasn't received any kind of information in our network interface card. So that's why still it is sending to the destination. Port 77 with the destination broadcast. Again, that server will receive that information. And now this is going to offer, basically now at this point, the IP will be assigned, and the server is basically acknowledgement, giving the acknowledgement to the host that the offer that you are looking for, I have already given you. So after that, you are going to get the IP here. And you know, to obtain automatically, you have to select this radio box. Obtain
you in an IT support field have seen that image, right? Heflin, Christelle.
Yeah.
And that's what it is. Like, you don't see that, but as soon as you click that button is basically, you know, clicked. That's where the process is happening behind the scene. Then.
Yeah.
This is slightly like the concept of this is slightly reminding me of how TCP does its handshake.
Yeah. Okay.
This seems very, like the idea of it seems very similar.
Yes, the idea is very similar.
Yeah, it's kind of like, yeah, there's a request, there's a reply, and it's similar, but of course it's using different protocols and different techniques to give out, because it's leasing things and all that kind of stuff is involved in.
So you also have to remember in a DORA process, what are the things that correlate to servers and what are the things that correlate to host machine. This is also one of the very good exam question as well as the interview questions. So the discover and the request belong to who?
Host.
Host, yes. And then offer and acknowledgement belongs to the DHCP server. Yeah. So this is also very good questions. They often ask offer and acknowledgement belongs to what? The server or the host. And also when you will hit, you know, the one concept, this is called as DHCP snooping. You have to remember what belongs to, what request belongs to the host and what belongs to the server. So you can use this DHCP snooping kind of security techniques just to avoid any the rogue DHCP server. I don't want to go a lot in detail. Just get the idea. So this is just the animation that is going on. Discover is sent, offer, receive, then request, and then at the end, it will send the acknowledgement. And now the DHCP client will receive the IP address and with some other information like the DNS, the default gateway, something like that. Any confusion? Because this is very important concept, and if you have any confusion, please do ask.
I also want to add is that when you guys are listening, or let's talk about DHCP, we're not just talking about Windows servers over here, because this process can be for anything, right? Like any networking devices, Linux, or any other, even in routers. You could have
Macs?
actually, yeah, anything. Like, for example, like DHCP is not something that when we most of the time when we talk about DHCP, I think most of our, sometimes you feel like we're just talking about Windows, that DHCP. You go into our trainings and you see sometimes we'll talk about, oh, this DHCP server. So the image in your mind, usually it's like Windows, right? But
yes,
that's not just Windows. Like we could have just Cisco devices and totally remove the Windows server out of it, and we can still give a DHCP addresses through the Cisco devices. And another example for you is in your home, you don't have any Windows servers running right now. You're still getting a DHCP addresses from your routers, right? So the process is universal. It's not just related to Windows. But the reality is that if you are a network engineer, and Kamran can also elaborate on that, most of the time we would have to have you will see that it's going to be a Windows server managing the DHCP, and that's where like DHCP relays or other things will play a big role in the future. You guys will learn about that. But that's where, like, we don't just use like a open source small service of a DHCPs from some other device that will offer these IP addresses. And that's very confusing for the person who's going for networking. They may think that I'm just going to learn about Cisco. But here, Cisco is actually relying on Windows servers to do that kind of stuff, to be honest.
Yeah. Another thing important, like we talked about, just a minute, if I can go. Okay. So usually, your Windows machine is, if the DHCP is not configured, you are going to get a PIPA. Very funny name, by the way. But on your routers, you are not going to get any kind of a PIPA kind of thing, because this is specific to Windows. In router, you get nothing, or even in the switches, because this switch interface port, you can also assign this as a DHCP. Instead of giving the IP, you can do the DHCP. But what if you don't get DHCP, or the DHCP is down? You will see you will not get any kind of IP or information, just like we are getting in a PIPA in a Windows.
I have a question.
Yeah.
In the situation, if we have a situation like you draw earlier, we have many DHCP servers.
Mm-hmm.
How do we make the one server, the DHCP? I mean, how the machine? I know that the host is gonna send a discover message. So how the DHCP server is going to respond? Because when you say 68, 67, all this, it's only the DHCP servers, but all the
yes,
DHCP
okay, I got your idea. So basically, as I said earlier, that whoever the DHCP server, let's say we have the server form and we have 3 or 4 DHCP servers, which is handing over the same subnets, okay? And whoever is going to hit that discover packet, he is going to entertain and he will be interlinked with that.
So is it
No,
kind of like first come, first serve? Like,
yes, exactly.
okay.
No other servers will entertain unless until they will get the request or the discover packet.
Okay, thank you.
Okay. So let's do a demo time. In demo, what I'm gonna do, because I cannot do, I cannot play with my LAN because this is what we are connected with session, and it will be disconnected. So I'm gonna use my wireless LAN for that, and I will show you this all process what we have gone through. So you need to click this capture options. Can you see?
Yep.
Yes.
Okay. So this is our LAN we were doing earlier. I don't want to play with this one because I want to IP config release and renew. If I will do that, our session will be disconnected. So for that purpose, I am using this is wireless network connections. So just click on that and double click, or just to start, because we had a previous session going on. It is saying that if you want to save, no, I don't want to save. You can save if for example, if you have some friend or some having a very good knowledge about the packet analysis, you can save this file and you can send via email as well. So we will just do continue without saving. As you can see, this is connected with my wireless network connection, and nothing is going on. Just a minute, let me check if I'm connected with the wireless. Yeah, I'm connected. If it is disconnected, you will not see anything, but you can see nothing is going on. Still, we have reached like 19 packets so far. Okay. So I will go into my command prompt and I will do, how many of you are familiar with this command ipconfig?
I'll tell you a really funny story about ipconfig release and renew. My
Okay.
second day on my job,
Yeah.
someone was having a problem, and I was like, oh, I was remoted into their machine. I was like, oh, you know what? I'm just gonna. It just seems like there's a problem with the IP address. But this
Okay.
lady was so much older. Like, she didn't even know what a router was. She didn't know how she was connected to the internet. So I ran an IP release on her machine, and then I was like, oh no. Now I can't communicate with her. She ended up restarting her machine, and it gave her a new IP address. But
and this happens a lot. This thing happens a lot.
I didn't think about it,
Yeah. So this thing happens a lot, and even if I do the same thing here, you will not hear me anymore. Okay, so Crystal as well, you are familiar with ipconfig release and renew?
Yes.
Okay, that's good enough then. So I have a question here as well. Just a minute, let me enable that thing for you. Can you see the command prompt?
Yes.
Okay. Okay, I have a question for both of you. I can do ipconfig/release, and this is gonna release the IP from where? Which network interface?
From your
From
your laptop or computer machine.
No, let's suppose we have two network interface cards. One is
Okay.
LAN, which is connected with my LAN network card or access point. Another one, I have wireless LAN, which is also connected with access point, but through wirelessly. So if I do ipconfig release, what's gonna happen? Which is gonna, yeah.
Sorry, I have a question. Are they both configured to DHCP?
Let's say yes. Yeah.
Can you specify which one you want it to release from?
No, I'm just saying I'm just going to run this command ipconfig / and then release. Which is gonna hit first? This one or this one?
I'm gonna guess LAN.
Okay, how about the Crystal?
I will say both of them. I really don't know.
Okay. So it is gonna hit the LAN first.
Always?
Always, because every network interface card has some kind of identification. Like 1 is connected with the LAN, then 2 is connected with the wireless LAN, then
Can you
3
change that configuration?
VMware. Yeah, sorry.
Is it possible to change that configuration? So like, can we make
Yeah, this is my
VMware
question.
1?
Yeah, this is where I'm heading.
Okay, sorry.
No problem. So what in case I just want to release the IP for my wireless LAN? Have any idea? And this is the thing, most of the people really, to be very honest, even they're at the highest level network engineers, but they still don't know. They go manually to the wireless LAN card and they will do release and renew, but will not do from here. Any idea, or I will continue?
No idea. I mean,
Okay.
I would put like the question mark to see.
Yeah, okay. Yeah, so which is the option you're gonna use? Just quickly, if you can answer.
Release con?
Yes, exactly. This is the one. So I am interested, my wireless, which is connected, I just want to release from that wireless LAN. So what you can do, you can type ipconfig, then you will do release, and you have to mention, but first of all, I need to know where that is connected. If I will do, just a minute, let me clear the screen, ipconfig / all. Here is the identification. It is connected on the number 2. So I have to use this identification to release. Okay, so I'm going to release, and meanwhile, let me make sure that I'm connected to my Wireshark.
Sorry,
So
quick question. So you would just type in ipconfig / release and then number 2?
Yes.
Okay.
And then I'm going to select 2. Or I think static 2. So as you can see, it has released, and we can see some activities going on. Okay, now I need to stop this one because I am interested in a DORA process. So just let's start again the same wireless LAN connection and click on start, continue without saving. Just a minute. Because wireless LAN currently is not connected. So this is the issue. So we have to connect that one. As you can see, nothing is going on. Now from here, if you try to connect my wireless LAN or the access point, you can see the packets begin to generate.
Look at it starting from that 000. Remember in that
Yes.
slide we talked about?
Yes.
And I can be more specific. I forgot to mention the other name of DHCP is boot P address. So this is the old name, and this is the new one.
I feel like that you will see in Linux versions more, that boot P. I've seen that a lot. But maybe they're still using that. But I've seen a lot of Linux distribution using boot P like that.
Yes, this is the old name, and even I do come across with so many troubleshooting with using boot P. We had so many guests in our hotel, and a strange thing I found means if I am trying to connect using DHCP, it is not connected, or it's not connecting. It's not handing over the IP. It is giving me the APIPA IP. But when I change it to the old the name, the boot P, it hand over the IP. So that was a very strange scenario I come across. But then I find out that that was a problem with my old Cisco router, which support boot P, not DHCP. So how you can, another thing you can verify the, if I can type DHCP, we can see we just filtered out the DHCP. But if I type here again the boot P, you will see the same thing again. If you have any confusion, let's suppose if
I love how Wireshark also gives you those names, right? Look at Heifer and Crystal on the right side, said discover,
offer request.
It's so cool that you can have that kind of, clarity.
Exactly. The thing that we just discussed, we can actually see there. So these are the same packets we talked about, DORA process. Discover, offer, request, and acknowledgement. As you can see, the source is 0000. It is going to the destination, which is the broadcast. And the protocol that I'm using is DHCP. In return, I receive the source is 192.1, which is going to be offer. So this is the IP of my server, this access point. It is going to give me the offer, which is going to where my machine basically. Then we have the request, because the client machine is now going to request that offer. As you can see, still it has a source address 0, and it is sending to the destination as broadcast. Then in the end, it is going to get the IP, but still, acknowledgement, after the acknowledgement, you are going to receive the IP. So you can see still it didn't get the IP. If I just can expand this discover, so you can have the better understanding what is going on. By the way, it used the UDP, user datagram protocol. So the DHCP, I do remember in a Discord, Crystal, and they raised the question that this DHCP is a protocol. Which is not, I can say, we sometimes call DHCP protocol, sometimes we call the service. And what is protocol? Protocol is nothing, if you are familiar with a layman example, if your prime minister or president, when they come to your local, like he come to meet the local people or the public, they are given some kind of protocols, which is just set of instructions.
Like standard.
Yes, exactly, the standard. So what if I'm calling DHCP as a protocol? So what? Because it is following some standards. Even the Ethernet. Some people call Ethernet a protocol, some call it a standard.
So they're interchangeable.
Yes, exactly. So not to confuse, okay? So what I was saying, DHCP travels on top of what protocol? The DHCP, the UDP. And you can clearly see here. Server will be using 67 for the UDP port, and the client will be using the port number 68. So you can take a look of these. Source port is 68, destination port is 67. Then we have some checksum and these timestamps. And then we have this dynamic host configuration protocol as well. As you can see, it is written protocol DHCP. It is going through what? Discover. And then you can see it is looking for some information from the server.
I'm sorry, I have maybe a very silly question.
Yes.
Wouldn't you want it to be like more, not secure, that's not the word I'm looking for, but wouldn't you want to use TCP instead of UDP because you know it's going to, because of the acknowledgement that happens before?
Okay.
So nothing is lost?
Yes, very good question. Why we can't use the TCP instead of UDP? Yeah.
Yes.
The problem is TCP has to go through what? Syncac, these things first. Okay. And we do not need any kind of, the security in this because we want to get the IP as soon as possible.
Okay, understood.
Because if we will use the TCP, you just keep waiting maybe 1 minute and then you will receive, or 2 or 3 minutes. Maybe there's some kind of checksum errors and then you will have to go again the process. Okay. So,
and think about it. You have 1,000 machines and they go to sleep and then they have to be turned on again. I mean, this checking again and again would be a problem, right, in a network. So much traffic will be flowing through these networking. So that's going to be a problem. That's why some protocols are used for a reason, like videos, we usually use UDP, and voice we use UDP. Anything that we feel like we want to do this in a quicker way.
Yeah.
Got it.
So another identification to know that what kind of protocol DHCP is using, you can check the protocol number, which is 17, which correlate to the UDP. Okay. And this is enough for this. You can go through these all things, and these are not so difficult to understand. If you have basic idea what is discover, offer, request. So as you can see, this is the offer, and you can correlate with this as a destination IP, which now has become the source, and this has become the destination. Is my host machine.